Good morning, everyone. Welcome to the class. We have been discussing synchronous counter analysis. What we have done earlier is basics of sequential circuits. What is memory element? What is the functions of memory element? How it can fulfill when we are using NOR-based and NAND-based memory elements. What was the problem in the NAR-based and NAND-based memory element and how those are rectified by using a control signal we made it is a latch. After getting latch also, what we observed, it is a level triggered, continuously responding to the inputs. To make it edge triggered, we are using latches to construct a flip-flop. There we have seen that constructing positive edge triggered flip-flop and negative edge triggered flip-flops. Then what are the parameters we need to consider about a flip-flop, which is a flip-flop delay, setup time and hold time? What is the reason for these also we have discussed. Then we started discussing counter designs. In that we started with synchronous counter design as well as synchronous counter analysis. So now let us see some more questions on synchronous counter analysis. When counter circuit is given, we need to find the sequence. Let us see how we are getting questions in competitive exams and synchronous counter analysis is by giving counter circuit. Check it correctly, observe correctly. By giving counter circuit, they are asking what is the sequence it is going through, what is the next state for a given present state, what is the next state after X number of clock cycles, that X may be more than modulus or less than modulus. Next is by giving counter, they are asking what is the modulus of counter. This type of different questions we have been getting. And one more advanced level of the question is this counter can be used as a divide by 2 clock or divide by 4 clock or divide by 7 clock. This type of questions also we have been getting. In electrical itself, they have given a question in 2020 gate. By giving a counter circuit, the following counter can be used as then they are giving options divide by 2 clock or divide by 4 clock or divide by 5 clock. So how it is divided by and so we discuss until that please hold on. So by giving counter circuit they are asking what is sequence it is going through, what is modulus of counter, what is next state for a given present state, what is the state after X number of clock cycle, that X may be more than modulus or less than modulus. This type of questions frequently we have been getting. So, just a minute. Right. So questions is by giving counter circuit, they are asking what is the sequence it is going through, or like this we are getting the modulus of following counter is. Question is like this, the modulus of following counter is dash. The modulus of following counter is dash. Clock is synchronous. What is the modulus of counter given? Try to analyze this. Already we discussed how to proceed. Present state, present inputs, and estimating next state using characteristic tables of the flip-flops. Yes, start with the 0, 0. Start with the 0, 0. Q1, Q0, present state, present inputs. What is it here? J1, K1, J0, K0. Next state of Q1, Q0. What is J1 connected to? Q0, K1 connected to 1, J0 connected to, what is it? Q1 bar, K0 connected to 1. Start with initially 0, 0. Then what we get here? Q0 is 0, K1 is 1. Q1 bar is 0 bar is 1, K0 is 1. What is the characteristics of JK flip-flops? JK00, it is Q of n, 01 it is 0, 10 it is 1, 11 Q of n bar. 11 Q of n bar. What is it here? 00 Q of n, 01 is 0, 10 is 1, 11 is a Q of n bar. Q of n bar. Yes. Start with the 0, 0. Then we are getting inputs to this. J1, K1, 0, 1. What is the next state of Q1? 0, 1. Next state is what? 0, irrespective of present. J1, K1 is 0, 1. Next state is 0, irrespective of present. J0, K0 is 1, 1. Then what should I do? Complement of present. What is the next? Complement of present. So J0, K0 is 1, 1. Q0 presently 0. Yes. Next state is what? Complement of that. Any questions? I hope you are understanding. Simple thing is using these characteristics to estimate next state. Yes, J1, K1, we are getting 0, 1. So Q1 becomes 0 irrespective of present. J0, K0 is 1, 1. Then Q0 has to complement. Presently 0, complementing means it is 1. From the characteristics. So the next state is becoming present state. The next state is becoming present state. Then again, Q0 is 1, K1 is 1. Q0 bar, sorry, Q1 bar, 0 bar is 1, K0 is 1. So J1, K1 is 1, 1. J1, K1 is 1, 1 means Q1 has to complement. So 0 complement is what? 1. And J0, K0 is 1, 1. J0, K0 is 1, 1 means Q0 has to complement. 1 complement is 0. Any questions? Any questions? J1, K1 is 1, 1. Q1 has to complement. Presently 0. Next is 1. So J0, K0 is 1, 1. Q0 has to complement. 1 complement is 0. Yes. 1, 0 is present state. Now Q0 is 0. K1 is 1. Q1 bar. 1 bar is 0. K0 is 1. Then what we get here? J1, K1, 0, 1. Next is 0. J0, K0 is 0, 1. Next is 0. Then again back to 0. So what is state is going through? 0, 0, 0, 1. Next 1, 0. Again back to 0, 0. Again back to 0. What is the modulus of this counter? Answer is 3. Because the number of different states or distinct states counter is repeating is called modulus of counter. The number of distinct or different states counter is repeating is called modulus of counter. I hope everyone is understanding. It is clear. It is a modulus of counter. What is the modulus of counter now? It is 3. It is 3. Correct? Yeah, Ravindra Swami, there is no such uh, reason, right? So we want to design a counter using SR flip-flop also we can design. Just try. It is not like that. While designing counter itself, we take care that we don't get that SR11. While designing counter, so we are using excitation table. In the excitation table, did we consider anywhere 1-1? No. Check it correctly. So already counter is designed means for a specific sequence, counter is designed. While designing counter, I haven't used that 1-1 condition at all. Then there won't be possibility of getting 1-1 when you are analyzing counter also, right? What happened, Pooja? Where you are asking which cycle, this first cycle, second cycle, and third cycle. Please be specific while mentioning something. Yeah, I observed the students, some students already asked me, did you have any doubt that you don't have class today? Already I mentioned yesterday, right? See you tomorrow. I mentioned that means you have a class, right? Some people have been doubting, and also I observed the strength is also as much as yesterday. Was there any doubt that you don't have class today? Dinesh Sai, hold on. Please wait. Please wait. Let me go with step by step. Are you going to write 2021 gate now? Desai. Sorry, Dinesh Sai. Are you going to write gate 2021? So you want to know the answer for that question only? Please wait. I will discuss step by step. I'm not discussing because of 2021 gate. I've been discussing from these from many years these concepts. So we are not following gate questions. Gate questions have to follow us because when we are covering everything, right? Third cycle, next state must be 1 in Q1. Why? So here we have that 1, 0. Yes. But because of this, what we are getting inputs, Q naught is 0, K1 is 1. Q1 bar means 1 bar is 0, K naught is 1. Yes, J1, K1, 0, 1. Why do you expect 1 here? As JK 0, 1, what is next state? 0. When J1, K1 is 0, 1, Q1 next is 0. Are you getting doubt, Pooja? Right? Yes. Yes. Go with the characteristics if you are getting a doubt. XNOR gate. Question is reset condition. The sequence observed at Y is. They are giving four options. I am not giving options here. What is asked here? What is sequence observed at Y? Here it is Y. Only one bit sequence it is asked. It is not the 3-bit sequence. It is only 1-bit sequence. What sequence we get at Y? Right. What we can say here? Q2, Q1, Q0, present state. Present inputs, what is it here? D2, D1, D0. Again, next state, Q2, Q1, Q0. One by one, if you specify, what is D2? Q1 XNOR Q0. Check it correctly. Q1 XNOR Q0. What is D1? Q2. What is D0? Q1. So if I start with 0, 0, 0, initially reset condition, then what we get here? Q1 XNOR Q0. 0 XNOR 0 is 1. Q2 is 0. Q1 is 0. What is next data? 1, 0, 0. What is here? 1, 0. 1, 0, 0 is becoming present state now. Then Q1 XNOR Q0. 0 XNOR 0 is 1. Q2 is 1. Q1 is 0. What is next data? 1, 1, 0. Once again, 1, 1, 0. Then what we get here? Q1 XNOR Q0, it is 0. And Q2 is 1. Q1 is 1. Then what is next data? 0, 1, 1. And 0, 1, 1 is present state. 0, 1, 1 is present state. Then Q1 XNOR Q0 means 1 XNOR 1 is 1. Q2 is 0. Q1 is 1. What is next state now? 1, 0, 1. Now 1, 0, 1. Then what we get here? Q1 XNOR Q0 is 0. Q2 is 1. Q1 is 0. Then what is next data? 0, 1, 0. Then 0, 1, 0. 0, 1, 0 is becoming present state. Now Q1 XNOR Q0. 1 XNOR 0 is 0. And Q2 is 0. Q1 is 1. What is the next data? 0, 0, 1. Then what is the next data? What is the next cycle? 0, 0, 1 becoming present state. Now Q1 XNOR Q0. 0 XNOR 1 is 0. Q1 is Q2 is 0. Q1 is 0. What is next data? 0, 0, 0. But what is asked? What is the sequence on Y? It is 0, 1, 1, 0, 1, 0, 0 and getting repeated. Right? This is sequence. And we can observe options can be differently. What is it? Let us see. So this is cyclic, right? The sequence is cyclic. 0, 1, 1, 0, 1, 0, 0, then 0, 1, 1, 0. If I write that all these, so what is the next one here is the next, again, it is getting repeated. If I write that, so options may be given differently. Don't get confused. So what is it here? The next again, what will be that? 0, 1, 1, 0, 1, 0, 0. Then again 0, 1, 1, 0, 1, 0, 0 and goes so and so. So if I started with this, this is the end of this sequence which is getting repeated. If I started with 1 next bit, then it is ended with 0, 0, 0, right? So if I start with again with the next bit, what is it here? If next one it is started, it is up to this one. So options can be like this. Don't think that only what we are observing on this. No, it can be differently options like this. What are the sequences we can see? What is here? 0, 1, 1, 0, 1, 0, 0 and getting repeated, or 1, 1, 0, 1, 0, 0, 0 repeated, or what is here? 1, 0, 1, 0, 0, 0, 1 repeated and so and so. It can be anyone. Not only this 0, 1, 0, 0, 0, 1, 1 and getting repeated, because it may be started with the next bit also. So like that, it may be given any one of these, right? All possibilities are correct. So it may not be given from the initial bit it is specified. It may be given from next bit. It may be given from next bit. It may be given from next or next or next. Whatever be the correct options are. In the options, there can be anyone. Or one more problem here is, as we have MSQ. Right? There is a possibility for getting all these 4 options in the given, then 4 should be chosen correctly. Am I right? The sequence which is getting repeated can be from first bit, can be from next bit, can be from next, or so and so. So they may be giving 2 or 3 or 4 options also correct. So these can be the multiple select questions. Check it. So observe correctly, there may be multiple options also. Correct. So in these questions, it may be given multiple. It may be given multiple options. Easy, right? To frame MSQ in this, it is easy. Only one option means it may be given any one of these. If it is a MSQ, it can be given all these answers. The options. Options. Very good. Very good. Many of you have done correctly. Next. The modulus of counter is dash. Some of you are very much enthusiastic to see questions with multiple flip-flops or different types of flip-flops. Try. Everyone should try. Sorry, K is connected to 1. Sorry, I forgot to mention that K is connected to 1. Sorry. Yes. Thank you. Thank you. Please check. K must be 1 in this. K is 1. Yes. Please check. Triveni, Subhash. What is the modulus of counter? Yes. So if I consider Q2, Q1, Q0 present state, then present inputs J, K, T, D, and next state is Q2, Q1, Q0. Right? What is J connected to? Q0 bar. K connected to 1. T connected to Q2. D connected to Q1. Yes. Start with 0, 0, 0. Then let us see what is the inputs now. Q0 bar. 0 bar is 1. K is 1. Q2 is 0. Q1 is 0. Then once we are getting inputs from the present state, what we are doing next state, estimating next state. JK11, JK11 means JK flip-flop state must be complementing according to characteristics. JK11, Q of n plus 1 is Q of n bar. Next state is complement of present. What is presently Q2? Because JK flip-flop state is what? Q2. Presently 0. Next will be 1. Toggle flip-flop T input 0. T input is 0 means next state is present state only. Toggle flip-flop T input 0 means next state is present only. T equals to 1 means next state is complement of present. When T equal to 0, what is the T flip-flop state? Q1, presently 0, next also same, which is 0 only. When T input is 0, next state is what? Present state only. What is T flip-flop state? Q1, presently 0, next also 0. When D flip-flop D input is 0, what is next state? 0. Because whatever we are giving on D will be the next state. Whatever we are giving on D will be the next state. Yes. So 100 is the next state. Now, in next clock cycle, 100 is becoming present state. Then what should I do? Q naught bar. Let me derive inputs based on 100 state. Q naught bar, 0 bar is 1, K is 1. T is Q2 is 1 and D is Q1 is 0. Am I right? JK11, then complementing Q2. JK11 complementing Q2. 1 complement is 0. T flip flop, T input is 1. Then next state of Q1 is what? Complement of present. T equals to 1. Next state is complement of present. Presently 0. Next is 1. D flip flop, D input is 0. Next state is what? 0. Next 0, 1, 0. What is it here? 0, 1, 0. Then what we get here? Q naught bar, 0 bar is 1, K is 1. So Q2 is 0, Q1 is 1. So JK11 complementing Q2, JK11 complementing Q2, 0 complement is 1. T flip flop, T input is 0. Next state is what? Present only. Check it correctly. T flip flop, T input is 0. Next state of Q1 is present only. That is 1 only. D flip flop, D input is 1. Next state is 1. So 111 is becoming next state. That 111 is a present state at next clock cycles. So 111 based on 111 deriving inputs Q naught bar 0, K is 1, Q2 is 1, Q1 is also 1. Then JK01 next state of JK flip flop will be 0. T flip flop T input is 1. Next state of T flip flop will be complement of present. Presently 1. Next is 0. D flip flop D input is 1. Next state is 1. Next state is 1. Right? Next 0, 0, 1 is the present state. Right? Then Q naught bar 1 bar is 0. Then K is 1. Then Q2 is 0, Q1 is 0. Then JK01, next state is 0. Next state is 0. Then what is the next one? T flip flop, T input is 0. Next state of this must be 0. If T input is 0, next state is again back to 0. What is sequence it is going through? 0, 0, 0, 1, 0, 0, right? 0, 1, 0, then 1, 1, 1, next 0, 0, 1, again back to 0, 0, 0, again back to 0, 0, 0. Then what is the modulus of the counter? 1, 2, 3, 4, 5. So answer is 5. The modulus of this counter is 5. These 5 states are called, what is that? Use state. How many states total? 8 states, because I'm using 3 flip flops means 2 power 3 states, it is 8 states. So in 8 states, these 5 are used states. Remaining are unused states. Remaining are unused state. So let us see what happens if it is getting into unused state. Unknowingly, counter is getting into unused state. Unknowingly, counter is getting into unused state. Let us see what happens. Once again, what is it here? So these are used states. Remaining are unused state. Counter is not getting into unused state. That's what our assumption. Unknowingly, when system is started, unknowingly it is seen unused state. What may happen? Let us see. What may happen? Let us see. So what is that unused state? First one, 0 is there, 1 is there, 2 is there. 0, 1, 1, 3 is unused. What happens? Let us see. 0, 1, 1 is unused. Then what happens? Let us see. Q naught bar, 1 bar is 0, K is 1. Q2 is 0, Q1 is 1. Correct? This is what we are getting inputs based on 0, 1, 1. It is same. It is already discussed. But what happens if counter is getting into unused state? Then let us see. What is here? If I use that 0, 1, 1 is unused state, unknowingly counter is getting into this unused. Then what happens? Yes, based on this, if I am deriving inputs 0, 1, 0, 1 and JK01, next state is 0. T input is 0. Then next state of T flip flop must be present only. Presently 1, next is also 1. D flip flop, D input is 1. Next is also again 1. Next is also again What is it here? 0, 1, 1 is present state. What is next state? 0, 1, 1. 0, 1, 1 present state again. Next state is 0, 1, 1. So even though you are applying clock cycles for years, it will be in 0, 1, 1 only. Then what is this called? What is this called? What is this called? Lockout. Lockout. Counter is locked in the out of expected state. Is nothing but a counter is going through unused states only. Here it is lockout. Counter is locked in the unused states only. It is not coming back to used states. Unknowingly, if it is entering into unused state, if it is going through unused states only, that is called lockout. Is it coming back? No, it is not coming back to the used, because the counter is designed to go through 0, 4, 2, 7, 1 back to 0. But unknowingly it is entering into unused state. Then what we are observing? It is going through unused states only. Let me name it as a lockout. So important thing, because I can frame a question, simple question. By giving counter circuit, I will give statements like this. Modulus of counter is 5. If counter is entering into 0, 1, 1, it is getting into lockout. Right? And some more words are there about counters, which we have been using generally. Most of you may be new to this type of concept, this type of discussions. Please understand correctly. They have been framing questions, especially in ISRO and other exams. People have been framing questions based on this. Once they have given in GATE exam also about lockout. By giving counter circuit, they have given in the option statements for 0, 1, 1 lockout, for 0, 1, 0 lockout, and so and so. There won't be any lockout in this. This type of statement they have given in the options. Right? So first of all, we should know what is lockout, right? What is lockout? If counter is entering into unused state, if it is going through unused states only, then it is called lockout. If counter is going through unused states only, then it is called lockout. Then it is called lockout. Right? This is one unused state we have verified. Let us see another unused state also. Another unused state also. Which one is that? What we have next one is 101. Yes, 101. 101 is an unused state. If counter is entering into 101 unused state. Yes, Q naught bar 0, K is 1. Then what is Q2? 1. What is Q1? 0. When JK01, what is the next state? 0. When T input is 1, what is the next state of toggle flip flop? Complement of present. Presently 0. Next is what? Complement of that. It is 1. T input is 1. Next state of this Q1 is complementing. 0 complement is 1. So D flip flop, D input is 0. What is that? Next state is 0. What is next state? 0, 1, 0. What is 0, 1, 0? Use state. What is it here? It is use state. What do you mean by this? So even though it is entering into 101, even though it is entering into 101, it is coming back to 010, which is use state. Once it is coming back to use state, it is going through these states only. Even though counter is entering into unused state 101, the next state is 010. Once it is entering into 010, it never goes to 101 again. 010 next state is specified for each and every these use states. Next state is specified. It is going through use states only. Let me name it as a, what is it? Restarting. Restart. Counter is restarted. And let us verify one more unused state. One more unused state. Which one is that? 110 unused state. 110 unused state. Then Q naught 0 bar is, what is that? 1, K is 1. Q2 is 1, Q1 is 1. Check it correctly. I hope you are understanding how I am writing these inputs, sir. So from these expressions, from this present state, we are writing these. What is it here? Q naught bar, 0 bar is 1. K is already 1. So Q2 is 1, Q1 is 1. Yes, JK11 means next state of JK flip flop is what? 1 complement is 0. I hope you are understanding. JK11 means JK flip flop state is complementing. 1 complement is 0. T flip-flop, T input is 1. What is the next state of T flip-flop? Complement of present. 1 complement is 0. As D flip-flop, D input is 1, next state will be 1. Again it is restarting, because 0, 0, 1 is use state. Once it is coming back to 0, 0, 1, then it is going through use states only. Again it is restarting. It is restarting the counter. Right. What is lockout? If counter is going through unused states only, is called lockout. If counter is coming back to used state, then it is called restart. And one more word is there about counters. What is it here? For each and every state, if you are observing that is restart, for each and every unused state, if you are observing there is a restart, then we can say, if this is also restart instead of lockout, if this is also restart, then we can say it is a self-starting. Counter is having self-start. For each and every unused state, if it is coming back to used states and going through used states only, then we say that counter is having self-starting. Counter is having self-starting. Each and every word is important. By giving counter circuit, they have been framing these statements in the options. Right? Unknowingly counter is entering into unused state. If it is going through unused states only, instead of coming back to used state, if it is going through unused states only, then we say it is lockout. If it is coming back to used state, may not be in one cycle, in 1 or 2 or 3 clock cycles. If it is coming back to used state, then it is called restarting the counter. And from each and every unused state, if you are observing there is a restart, then we say that counter is having self-starting. Even though it is entering into unused state, it is coming back to used states. It is going through used states only. That is called self-starting. Self-starting. Yes. Sunita Desai. Yes, Pratik Pramod, please hold on. Right. See what we are observing here. Used is nothing but a counter is designed to go through these. Which are those? 0, 4, 2, 7, 1, back to 0. These are called used state. So you are saying that modulus of counter is 5. And which 5 is this? This 5. This 5 are called used state. Whichever the states are missing in this 5, those are called unused state. Sunita Desai. Don't get confused. I'm there to help you. Right? Don't get confused. Clear? Still any doubt? Sunita. When counter is started with 0, 0, 0, whichever the state you are expecting, those are called use state. What do you mean by, do you want to me give you any formula for that? Wait, Bhaskar, I will define. It is not present state. It is a input, present input. Check it correctly. Anand, the wording used to be correct. So it must be present input is Q2. Based on the present state, present input is Q2. Yes. So how to find used means used states are nothing but the counter is designed to go through these only. So remaining are unused. And what is your doubt? I'm not able to understand. Please. Please elaborate your doubt. I will help you. Yes, it is possible. Every counter may not be having lockout. Lockout is a problem. Yeah, we can design Jaswant. Starting state may not be 0, 0, 0. We can start. Lockout is not self-starting. Ajay, I will discuss once again about that. Just let me give clarity about people have been asking that which are used and unused. Let me consider that. Once again, I will explain about this lockout and self-starting. Please hold on. Right? Please hold on about right used and unused. Right? Whichever the states you are expecting to count, please stop typing. Please hold on. I will discuss about lockout and self-starting once again. Please hold on. So let me give clarity about used and unused. Whichever the states you are expecting to count, these are called used state. Used means whichever the state is going through. And whichever the states are not skipped, those are called used state. Whichever the states are to be skipped, those are called unused state. Counter is designed to go through these only. These are called used state. And the remaining, whichever the states are missing, because 3-bit vectors means 3-bit states means 3-bit vectors means there are possible 8. In 8, 5 are used means remaining 3 are unused only. Remaining 3 are unused only. So that's what we need to understand. Used and unused. Used combination, unused combination. Hold on, Rajendra Kulkarni. Please, I will give you all that stuff. Right? Please understand. Let me give clarity. Right? Yes, yes. I think Sunita, have you understood that? Please reply. Right. Yes. Used and unused. Yes. If it is going through used state, there is no problem. There is no problem. But unknowingly, if counter is entering into unused state, for that unused state, if that counter is resulting again unused state, from that unused state again going through unused state, it may be going through unused states only. That is called lockout. If counter is going through unused states only, that is named as a lockout. That is named as a lockout. Once again, unknowingly counter is entering into unused state. Unknowingly counter is entering into unused state. What is that here? If it is going through unused states only, then only we name it as lockout. Counter is locked. Counter is in lockout state. Right? And every time it may not be lockout. So other case we have understood what is it here? Unknowingly, if it is entering into this unused state, what is next state is seen? One of the used state. If one of the used state means it is pushing back to used state. Once it is coming to used state, it is going to used states only. It never goes to 101 again. It never goes to 101 again. Understand point correctly? So it is pushed back to used state, then it is going through used states only. It is going through used states only. Then it is right restarting the counter on its own. On its own. This one is also, if you are observing 110, is resulting next state is 001. That means next state is 001. For 001 is next state 000. Then again it is going through this used states only. Right. What is lockout once again? If counter is going through unused states only, it's called lockout. And if counter is coming back to used state, unknowingly entering into unused state, from that unused state, if it is coming back to used state, then it is called restarting the counter. What is here? Restarting the counter. For each and every unused state, if it is coming back to used state, then we say it is a self-starting. When can we say it is self-starting? For each and every unused state, if it is coming back to used state, then only we say it is a self-starting. For each and every unused state in the counter, if it is having a next state is used states or if it is coming back to used states only, then we say it is having self-starting. So in this case, it is not having self-starting. When can we say it is self-starting? For 011 also, if it is resulting back to used states, then we say it is having self-starting. When can we say it is self-starting? It is not having self-starting. Don't assume that these cases are conditions for self-starting. I did not say that. What I mentioned while writing state self-starting for each and every unused state. If you are observing it is coming back to used state, then it is called a self-start. Counter is having self-start. One by one again, please understand the words correctly. Yes, Rajita, with next state only we can say that, right? If next state is unused, then only we can say it is a right. Yes, yes, Bhavani, yes. So what I can say here is while designing the counter, what is the reason for all this is while designing counters, we have used these are don't cares. While designing the counter, we have used these are don't cares. Don't cares may be utilized, may be neglected, may be considered as one, may be considered as zero. That is the reason it is problem which is a lockout. Understand correctly? While designing counter, we have considered these unused states as don't care. Don't care may be utilized as one, may be utilized as zero. That is the reason this problem has been occurring. This problem has been occurring. So for each and every unused state, if you are specifying next state is one of the used state, then it never gets into lockout. Put it here while designing the counter. Listen, most of you are asking that how to come back from lockout. So how can we eliminate lockout? How can we eliminate lockout? While designing the counter for each and every unused state, instead of considering as don't care, if you are specifying next state must be one of the used state. Even though it is entering into unused state, it will be coming back to used state. Then what we can say? It is having self-starting. For each and every unused state, if you are specifying what must be the next state, instead of considering as a don't care, if you specify what must be the next state for each and every unused state. Yes, 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 right? So for each and every unused state, if you are specifying one of the used state as next state while designing the counter, instead of neglecting those states, instead of considering as don't care, if you are specifying what must be the next state for each and every unused state also, then it can come back to used state even though it is seen unused state on counter. Even though it is seen unused state on counter, it can come back to the used state on its own if you are specifying. If you are specifying which next state or which used state must be the next state for each and every unused state. Once again, while designing the counter for each and every unused state, if you are specifying next state is one of the used state. For each and every unused state, if you are specifying next state is used state, one of the used state if you are specifying. Anyone, not required to use 0, 0, 0 only. Generally, we do that. Each and every unused state, we go with what is that? 0, 0, 0. So, if you are observing, if you are right, if you have observed correctly, I can show you that. Yes. Here, 110111 we have considered as a don't care while designing the counter. This may be causing lockout. For for example, another possibility is for 110, right, next state is 0, 0, 0. For 111, right, next state is also 0, 0. Then we cannot use don't care. We cannot use don't care. Then we go with the specific right, next stage. Then we can design the counter. Even though it is entering into 110 or 111, it is coming back to 0, 0, 0. So generally we use 0, 0, 0, but not compulsory to use 0, 0, 0. You can use any one of used state. While designing counter, Instead of using don't cares for each and every unused state, if you are specifying next state is one of the used state, then even though counter is entering into unused state, it is coming back to used state. It never goes into lockout. It never goes into lockout. Is that fine? Still any doubts? So let me repeat once again. So unknowingly counter is, for example, some people maybe think that 011 means it must be 011 only. No, I did not say that. Other possibilities also, let me mention. 011 it has entered, then next state is 101. From 101 next to 110. From 110 again 011. See, the lockout may not be with only one state. It can be like this as lockout. If it is like this, if it is like this, I'm not saying that it will be like this. If it is like this, 011, 101, then 110, again back to 01. This is also lockout because here it is entering into unused and it is going through unused only. Need not to be 011 only. Example I'm mentioning. It may be going through unused only. Then it is called lockout. May not be only one state. People may be assuming that 011 must be 011 only. If it is 101 means next must be 101. I did not say this. If the counter is going through unused states only, then it is called lockout. Then it is called lockout. Then it is called lockout. Right? So another possibility. Some of you may be thinking that restart means for 101 next state must be used only. For 110 means next state must be used only. It cannot be like this also. Other possibility. Here also other possibility. What is that here? 101 next 110, then 000. Then also it is restarting. Check it correctly. 101 is unused. Right? In next state is not used. Next state is also unused, but again from that unused it is going to 000. It is used. It may not be in one clock cycle to coming back to used. It may be coming back to used after few clock cycles. That is also restarting. So, right. Once again, clarity, please. And most of you may be new to this concept, sir. That is the reason I'm expecting this type of questions, sir. And I've been saying that propagation delay questions are very important, and we have been getting questions every year. Last year, 2 questions only on propagation delay. 2 questions only on propagation delay. Please understand correctly. So each and every point is important. Each and every concept is important. So what we are observing here is if counter is entering into use state, it can go through use states only. Then we can say what is the modulus of the counter. If counter is entering into unused state, the possibilities are like this. It may be going through unused only. If the counter is entering into unused state, if it is going through unused only, then it is called lockout. If the counter is entering into unused state, it may be coming back to used state. I'm not saying that next state is used. It may be coming back to used state. Then it is called restarting the counter. Counter is entering into unused, going through unused only is called lockout. Counter is entering into unused state, then it is coming back to used state. I'm not saying that next state is used. It is coming back to used state. After few clock cycles also, it may be coming back to used state. That is called restarting. And what is self-starting is for each and every unused state, if you are observing there is a restarting, then it is called self-starting. Beauty of the concept. Very simple thing. Generally, we can understand, right? Lockout. What do you mean by this? Out of use state, or it is going through unused state. So it is called lockout. So it is not coming back to use state. It is going through unused only. That is called lockout. So from unused state, after few clock cycles or one clock cycle, if it is coming back to used, then it is called a restarting. For each and every unused state, if there is a restart, then we say it is a self-starting. It is self-starting. Counter is with respect to state, we say it is restarting. With respect to one state, we say it is restarting. With respect to counter, we say that self-starting. What I mean is, for each and every unused state, if you are observing restarting, then it is called counter is having self-starting. One by one correctly. Counter is going through used state. We can calculate modulus of the counter. Counter is entering into unused state. Then if it is going through unused states, only la counter. If counter is entering into unused state, if it is coming back to used state, then it is called restarting. For each and every unused state in the counter, if you're having restarting, then we say that counter is having self-starting. Still, anyone has any doubt? Right? The same example I can complete in 2 minutes. I can complete in 2 minutes by discussing till this point only. Point should be understood correctly. The same example I can complete in 2 minutes by discussing till this point. To cover these concepts which are at next level, when there is a question at next level, to answer that question, all these concepts is important. If I don't introduce, you may not be knowing these concepts at all. Right? To cover this in depth, it takes more time. Please understand why I've been mentioning to this batch, especially these words, you need to understand. Why I'm mentioning is that it is taking more time to cover all these concepts. If you are expecting this type of coverage, yes, obviously you have to spend time. That's what I've been doing from day one. Instead of giving simply shortcuts and completing with examples that I cannot do, that I don't want to do. To cover concepts in depth, it takes time, right? This also with one or two statements, by writing the statements, I can complete. But my intention is everyone should understand each and every word I'm mentioning. Once, twice, thrice, changing the explanation. I hope I have reached your minds, right? You are able to understand what is that lockout, what is the restarting, what is self-starting. Is anyone having doubt? Please spend effective time. I'm there to help you. I'm there to help you always, right? To cover this in depth, yes, you have to spend more time. Then obviously I can cover the concept, because one question is sufficient to change our fate or luck or life itself, right? One question, if you are doing wrongly, instead of getting 2 marks, right? Now we are losing the 2 marks. And again, if you are doing a mistake in that multiple choice question, again 0.66. So instead of +2, now it is a minus 2.66. That one question is sufficient to be out of 100 when you are expecting in 100. So that is the difference you are observing, that around 4.66 because of one question. That is the reason I say always, whichever the subjects you are comfortable, there let us be 100%. If you're not understanding anything, leave it. But if you are able to understand something, let us see in depth in that. Because any question we are getting, we must be in a position to solve. That's what my intention. So please take these words in a positive way. I'm there to help you in understanding the concepts. I cannot help you in the exam, but I'm there to help you in understanding concepts in a right way. Thank you, Gopal Krishna. Right? Right. Thank you, Akash. Thank you, Pranita. Right. Yes, sir. Thank you, Bharat. Yes, Bhavani, I'm trying my level best. The concept which I know, I try to convey my best. Right. So let us be at our best at our best. I'm not saying I'm the best. I never say that. If I'm saying that I'm a fool, I know that. I'm not saying that I'm the best, but let me do my best. For that, please, I'm seeking your interest as well as dedication. So when I'm discussing, focus on my words. When I'm expecting some more time, please have some patience and don't create any problems. Already told you this subject. Yes, this is a subject I can complete in 20 hours. Effectively, 2 full days I can complete the subject, but to cover have been taking right more and more hours. That depending on students' interest only. If you are creating problems like I heard some of you have sent a mail or complained regarding more number of hours in a day. Yes, it is happening because of I'm trying to cover this in depth. Otherwise, it is not required. By this time, I would have closed. Right. That much is not there, Ajay. I'm not doing like that. So I'm doing my duty. That's it. Yes. So anyone has any questions, you can type in the chat box before going to next question. Right. It's not like glitches, Rajendra. It's like when counter is started, depending on where it has stopped, which state. In the off condition, there may be dischargings. The dischargings may be completed on some flip-flops. Some flip-flops may not be discharging. In such cases, there is a possibility for seeing unused state when counter is started. That is the reason all these can be eliminated with one. It is actually design concepts not required for our competitive exam, but I'm giving that. This problem can be eliminated. This problem can be eliminated if you are not seeing unused state. Am I right? If it is not seen unused, there won't be any such problem. How can we make it? Where is the possibility of entering into unused data? Where is the possibility of entering into unused data? When counter is started or system is started. When system is started, if you are having power on reset, point should be understood correctly. Power on reset. If every system is designed with power on reset, there won't be possibility of seeing unused, there won't be possibility of lockout. Simple thing. A design concept, but as someone has asked, I'm giving this information. But for our exams, it is not required. Right? Right? So, yes. What we call the counter. For what, Kumar? For what? For what you are asking about that, what we call the counter? Yes. Very good question, Abhijit. Immediately I expected this question. Yes. If it is 0, 0, 0 itself is unused, then power on set. Or simply we can say power on initialization. So a flip-flop can be set or reset on power on. Set or reset. So what we can say here, power on initialization. When system is started, when power is on, it is entering into one of the use state only. That is called power on initialization. Power on initialization. Yes, Abhijit. Right. Different. Chakrabarti, it is different. That's what I'm saying, Manisha. It may not be 0, 0, 0 also used. 000 is also unused sometimes. In such cases, what we say, power on initialization. When system is started, it is getting into one of the use state. Yes, Kumar. If counter is entering into unused, if it is going through unused states only, that is called lockout. That's it, Kumar, 100%. For each and every unused, if it is coming back to use state, then we say that it is self-starting. It is self-starting. Right, right. I hope I'm clear. Right, I'm clear with the concept which I would like to convey. Right. Is it possible to force reset after 3 states? Such type of special counters I'm going to talk. Hold on. Yes, we can do. We can write insist a 0 after few states again, remaining states may be going through. That type of counters I will talk later. Gopal Krishna Reddy, please wait. Right. Right. Yes, Praneeth, that's what I talked. Right, it can be 000 or it can be 111 power on set or power on reset. If not this, some flip flops can be set or reset. That means I can see any of the states when system is started. So when system is started, counter is started, I can see any of the states. It can be any one of use state, any one of use state. Right now. Assuming initially all the flip flops are in reset condition, the state Q2, Q1, Q0 after ninth clock cycle. After immediately ninth clock cycle is after immediately ninth clock cycle is dash. After immediately ninth clock cycle is dash. So X is not derived from the state. X is supplied externally, bit by bit serially. At every clock cycle, we are supplying. Then what is the state Q2, Q1, Q0 after ninth clock cycle is? Then simple thing is what is it here? Present state. Present state, present input, next state. What is present state? Q2, Q1, Q0. What is present inputs? D2, D1, D0. What is D2 connected to X? What is D1 connected to Q2? What is D0 connected to Q2 XOR Q1? What is the next state of Q2, Q1, Q0? So 0, 0, 0 is initial. What should we apply first bit? Whatever is supplied here. So here, so we need to assume that it is starter, even though it is not mentioned. Starting bit is now it is 1. So what is it here? 1, 1, 0, 0, 1, 1, 0, 1, 1. These are bits we are supplying serially. Then what is it here? 0, 0, 0 is initial. X is the first bit is applied. Now Q2 is 0. Q2 XOR Q1 means 0 XOR 0 is 0. What is the next data? As these are D flip flops, 1, 0, 0. I hope you are understanding. First bit is supplied at first clock cycle. First bit is supplied. Now initially 0, 0, 0. Based on this, if we are deriving inputs, what we are getting? 1, 0, 0. As D flip flops are these, so next state will be 1, 0, 0 only. Again 1, 0, 0. Then what is it here? Q2 is 1. Q2 XOR Q1 is 1. What is the next state? 1, 1, 1. Now 1, 1, 1. Then what is it here? Q2 is 1. Q2 XOR Q1 is 0. Next state is what? 0, 1, 0. 0, 1, 0. Now 0, 1, 0 is becoming present state. Again Q2 is 0. Q2 XOR Q1 is 1. Next state is what? 0, 0, 1. Simple. 0, 0, 1. Q2 is 0. Q2 XOR Q1 is 0. Next state is what? 1, 0, 0. 1, 0, 0. Q2 is 1. Q2 XOR Q1 is 1. Next state is 1, 1, 1. So 1, 1, 1. Now Q2 is 1. Q2 XOR Q1 is 0. Next state is 0, 1, 0. 0, 1, 0. Q2 is 0. Q2 XOR Q1 is 1. Next state is 1, 0, 1. Next 1, 0, 1. Then Q2 is 1. Q2 XOR Q1 is 1. Next state is what? 1, 1, 1. After ninth clock cycle, the state we are seeing is a 1, 1, 1. After responding to ninth bit of X, the state is becoming 1, 1, 1. After responding to ninth bit, the state we are going to see is a 1, 1, 1. Yes, correct. Is a 1, 1, 1. Very simple, right? Bit by bit, we are supplying X serially and observing what can be the next state and deriving what can be the state after specific number of bits. After ninth clock cycle, the state will be 1, 1, 1. Dinesh Sai, how you get that? This is a state after first clock cycle. This is a state after second clock cycle. Don't observe here. What is it here? So you are counting here cycles. No. After first clock cycle, this after second clock. After third. Next to fourth, fifth, sixth, seventh, eighth. This is ninth. After ninth clock cycle. After first clock cycle is this, second clock cycle, third clock cycle, so and so, ninth clock cycle. Dinesh Sai. Dinesh Sai. Have you understood? What is the meaning of that immediately is after ninth clock cycle means you may be applying the 10th clock cycle also, 11th and 12th also. What happens here? After ninth clock cycle means what is it here? It can be after 10th or 11th or 12th also. It is after means you may be saying that. So immediately means after ninth clock cycle before occurrence of 10th clock cycle. After immediately. So yes, it is possible here because we are supplying externally data. It may be repeating a state multiple times, Anand Barur, right? What happened, Nitish Kumar? Here, for this present state, present input is applied and we are getting next state. This is what next state after first clock cycle. Then it becomes now present state. This 100 is becoming present state and we are applying externally again second bit. Now it is going to be second state or second clock cycle. What is the state? We are going to see 111. And 111 is becoming now present state. Again, we are getting inputs is 010. The next state is 010 after third clock cycle. So and so, fifth, sixth, seventh, so and so. After responding to ninth bit of X, the state is 111 after ninth clock cycle. After ninth clock cycle. Dinesh Sai, right? Okay, okay. Rajendra, not required. It cannot be that MSQ. No. Yes. Right. What is it here? We are supplying bit by bit serially on X. In which conditions we are going to see Z equals to 1? That is the question. So from the option, if you are observing, changing from 1 to 0, changing from 0 to 1, constant at logic 1, constant at logic 0 in 2 consecutive clock cycles. See, question is in 2 consecutive clock cycles, it can be 1 to 0 or 0 to 1 or 1 1 or 0 0. These are the possibilities. So let me consider X is like this. I am considering from the given options X equals to 0 1 1 0 0 1. If I consider X is like this, is it covering all? Yes. Changing from 0 to 1, constant at logic 1, changing from 1 to 0, constant at 0, changing from 0 to 1. Am I right? It is covering all. Changing from 0 to 1, constant at 1, changing from 1 to 0, constant at 0, changing from 0 to 1. Right? Let us see what is this. Yes. Present state Q1, Q0. Present inputs D1, D0. Next state Q1, Q0. Output Z Q1 and Q0. Output Z Q1 and Q0. So what is D1 connected to? X. What is D0 connected to? Q1 bar. Q1 bar. So let me start with 0 0. Now here X can be, what is it? We have considered 0 1 1 0 0 1. Correct? Now see, from this 0 0, what is it? Q1 bar means 0 bar is 1. What is the next state? 0 1. Am I right? What is the next state? 0 1. What can be the output? End of these two, 0. Now 0 1 becomes a present state. Then what is it here? Q1 bar. 0 bar is 1. What is the next state? 1 1. What is the output? 1. The 1 1 is becoming again present state. Yes, 1 1. Q1 bar. 1 bar is 0. Then next state is what? 1 0. What is the output? 0. That 1 0 is becoming again present state. Then Q1 bar. 1 bar is 0. The next state is what? 0 0. Output is what? 0. That 0 0 is becoming again present state. Then Q1 bar means 1. Next state is what? 0 1. Then again output is 0 0 because 0 and 1 is 0. Now 0 1 is becoming present state. Then Q1 bar means 0 bar is 1. Next state is what? 1 1. Output is 1. Output is 1. If you are observing, output is becoming 1 for twice. Twice X is changing from 0 to 1. Simple thing. This was a GATE ECE question, previous question, I think 2012 question, 1 mark question. Simple, 1 mark question. Simple, 1 mark question. Whenever X is changing from 0 to 1, there Z is becoming 1. And the synchronous, we have a next part is a register. Register. What is that register? Storage of multi-bit information collectively. Whenever it is required to store multi-bit information collectively, we are using, yes, Neeraj, from the given options, we have chosen X. Yes, it is not given, we have chosen because we are understanding the functionality of that. Yes. So now register. What is register? Whichever the circuit which is storing multi-bit information. When it is storing one bit, we consider it as a flip-flop. To store one bit information, we have used one flip-flop. To store n bit information collectively, we are using n flip-flops collectively. Is named as a n bit register. Collection of flip-flops. To store data collectively is named as a register. So to store n bit information collectively, we use n number of flip-flops collectively is named as a n bit register. To store n bit information collectively, we use n number of flip-flops collectively is named as a n bit register. So if I say example, a 4-bit register using 4 flip-flops. So to store 4-bit information, I'm using 4 flip-flops collectively. Sorry, that we do later. Yes, this is a 4 flip-flop. Let me say that D, Q, Q bar. No need to use D flip-flops only. You can use any of the flip-flops with the expected conditions. I'm using D flip-flops. Let me consider 4 flip-flops are synchronously clocked. 4 flip-flops are synchronously clocked. There is a clock. There is a clock. Right. This is a 4-bit register which can store 4-bit information. Which can store 4-bit information. Try to understand it correctly. To store 4-bit information, I'm using 4 flip-flops. We are naming it as 4-bit register. On this register, we can perform some operations also. What are the operations can be performed? Let us see. By connecting these like this. Then what happens here? When clock edge is occurring, for this flip-flop, whatever is there on D will be propagated to Q. That means whatever was here will be shifted to this. And for this flip-flop also, when clock edge is occurring, what is there on D? Output of this flip-flop. So that will be propagated to Q when clock edge is occurring, because whatever is there on D is becoming Q when clock edge is occurring. When clock edge is occurring, what is there on D? Output of this flip-flop, that is propagated to Q. Once again, when clock edge is occurring, whatever is there on D is becoming Q. Right? Yes. So what is happening here? Whatever was data available on this flip-flop output is shifted to this. Is shifted to this. Will be shifted to this. What about this first flip-flop? Whatever we are supplying externally will be the first flip-flop output. So externally, the data we are supplying will be the first flip-flop output, and at every clock edge occurrence, the data will be shifted 1 bit right, 1 bit right. Try to understand correctly. In this, what is happening? So we are making connections such that it is shifting right 1 bit data at every clock cycle. At every clock cycle, when clock edge is occurring, input for this flip flop is output of this flip flop. So whatever is there on D is propagated to Q when clock edge is occurring. That means whatever was available here will be shifted to this. Whatever was available here will be shifted to this. Will be shifted to this. So what about first flip flop? What about first flip flop? Whatever the data we are supplying externally, So at every clock cycle, we are supplying 1 bit. That will be the first flip-flop output. What about remaining flip-flops? Whatever was here will be shifted at every clock cycle. Then what is happening in this? Let us see. If the initial contents of register is 100, if the initial contents of register is 100, what will be the register content after a clock cycle? Shifting, right? This will be shifted to this 0, this is shifted to this. And let me say that we are supplying a 0 externally. Assume that we are supplying a 0 externally. What is happening here? In one clock cycle, it is shifted right. What about last flip-flop output? It is disappearing. It is not stored anywhere. So last flip-flop bit will be discarded or disappearing. So at every clock cycle, what is happening? These 3 bits are shifted right, and first flip-flop output will be the data we are supplying. Assuming we are supplying a 0, this is a register content after first clock. After one more clock cycle, what happens? Again shifting. Let me say that we are supplying a 0. Again one more clock cycle. What happens here? 0, 0, 1, supplying it 0. Right. Now, what is the register contents decimally assuming unsigned binary? It is 8. Here it is 4. Here it is 2. Here it is 1. Right. So, what is that 4? 8 by 2. What about 2? 4 by 2. What about 1? 2 by 2. That means it is giving divide by 2. Right shift operation is giving divide by 2. Understand correctly? Register contents are divided by 2. Whenever it is required to divide by 2, we can go with the right shift operation by appending a 0 in MSB. If you are appending a 0 in MSB and shifting the register content 1 bit right, we are getting divide by 2. Divide by 2. Don't say that, what about again by 2? No, it cannot hold because it becomes a 1 by 2 is 0.5. You cannot store here. So what is it here? So it is shifting right by 1 bit. Appending a 0 in MSB is giving division by 2. Is giving division by 2. What is it here? It is a division by 2. In the same register, if I change the orientation, let us see what is that. If I change the orientation, what do you mean by this, sir? Now, if you are supplying data X here, if you are supplying data X here, what is happening here? It is possible to feed information at LSB and it is possible to shift data left side. Data left side. Whatever was here will be shifted to this. Whatever was here will be shifted to this. Whatever was here will be shifted to this. And LSB, we are feeding data serially. What, right? At this point of, at this port, it is possible to supply data serially. Then if I say that 0001 is the register content initially, then let us see what is the register content after a clock cycle. Now it is a shifting left 1, 0, 0. It is shifting left. What about MSB is disappearing again, as we have seen earlier in LSB. So here this MSB is disappearing. So it cannot be stored anywhere. Now, if I say a 0 is supplied externally at LSB. Now, after one more clock cycle, what happens here? Again, it is shifting. Let me say it is 0 is supplied. Again, one more clock cycle. If I say register content, here it is 1, here it is 2, here it is 4, here it is 8. Then what is it here? Multiplication. So when you are shifting left the contents by appending 0 in LSB, it is a multiplication by 2. Multiplication by 2. The register contents are divided by 2 and also multiplication. Divide by 2 when you are shifting right. When you are shifting left, it is multiplication. If you are shifting again, what happens? It becomes 0, 0, 0. Then what is it here? It cannot hold 16. With 4 bits, maximum we can hold 1, 1, 1, 1. It is 15 only. So result will be 16. Result cannot be held with the 4 bits. Yes, it becomes 16. The 16 cannot be held with 4 bits. With the 4 bits. Right? It is shifting left by 1 bit by appending a 0 in LSB is giving multiplication by 2. If you are shifting right by 1 bit, appending 0 in LSB is giving division by 2. So in a register, these two operations we have observed. One is division by 2, other one is multiplication by 2. Multiplication by 2. Now, we can have some more operations also on these registers. Let us see what are those operations. In these registers, what we have done till now is in a shift register, in a shift register, in a shift register, in a shift register. So at every clock cycle, we were saying that what is 4-bit information, right? At every clock cycle, you are writing 4-bit information. At every clock cycle, you are able to say what is 4-bit information. That means it is possible to read at every clock cycle and every flip-flop output. What is it here? At every clock cycle, it is possible to read at output of each and every flip-flop. That we name it as a parallelly we are reading. What is here? Parallelly we are reading. So parallel reading is possible. Then only we can say what is 4-bit information at every clock cycle. At every clock cycle, we are saying that what is 4-bit information. Right? So at every clock cycle, we are able to say what is 4-bit information means. So it is possible to read at output of each and every flip-flop, that we name it as a parallel reading. What is it here? Parallel reading. It is a parallel reading. But now I say parallel reading is not possible. What is it here? It is not possible to read at output of each and every flip-flop. That means parallel reading is not there. That means there is a possibility for reading at output of last flip-flop only. Once again, in earlier discussions, what we said here, at every clock cycle, what is the 4-bit information we are writing? We are writing means it is possible to read. It is possible to read means parallel reading is possible. Parallel reading is possible because at each and every flip-flop output, it is possible to read data at every clock cycle. That is called parallel reading. Now, I'm saying that it is not possible to read at output of each and every flip-flop. It is possible to read at output of last flip-flop only. At last flip-flop output, how many bits I can read at every clock cycle? Only 1 bit. That means bit by bit we are reading. That is called bit by bit is nothing but always a serial operation, which is called serial output code. What we are saying here, at the last flip-flop output, it is possible to read. How many bits I can read? Only 1 bit I can read. Only 1 bit I can read. Understand once again? So at the last flip-flop output, it is possible to read only 1 bit at every clock cycle. That is named as a serially reading or serial output code, where we can read bit by bit serially. And also feeding information at first flip-flop input only. I'm feeding information bit by bit serially at the first flip-flop input. That we name it as a serial input port. That we name it as a serial input port. What is it here? Serial input, serial output. What is it here? Serial input, serial output. What is it here? Feeding information bit by bit serially, reading information bit by bit serially. So this operation is called serial input, serial output. Serial input, serial output, in which it is possible to feed bit by bit at first flip-flop input only. It is possible to read at output of last flip-flop only, bit by bit serially. So serial input, serial output. Now, if I feed 4-bit information at serial input port, for example, if I feed 1001 at serial input port, after how many clock cycle I can see at serial output port? Once again, if I feed 4-bit information serially at serial input port, after how many clock cycle we can say at serial output port. At a serial output port. Let us see what happens. Understand correctly? Listen carefully. First clock edge occurrence, I am feeding first bit information. First clock edge occurrence, I am feeding first bit information. After first clock cycle, after first clock cycle, output of first flip flop becomes 1. What is it here condition? After first clock cycle, output of first flip flop can be, what is it here? If I am applying that first bit 1, that will be the first flip flop output. What about remaining flip flops outputs? Unknown. If it is reset condition is there, we can say 0. But I don't know what is it initially. So let me say it's unknown. So this is the status of register after first clock cycle. After first clock cycle. Right. Now, second clock edge occurrence. Second clock edge occurrence, I am feeding second bit. Second clock edge occurrence, I am feeding second bit. After second clock edge occurrence, what is the status here? 0 will be available here. Here it will be 1 because the 1 was here will be shifted to this. This is the status of register after second clock cycle. After second clock cycle. Now, third clock edge occurrence, I am applying third bit. Third clock edge occurrence, I am applying third bit. Then after third clock edge occurrence, what is it here? It is 0. The 0 will be shifted. The 1 will be shifted to this. The 1 will be shifted to this. This is status of register after third clock cycle. After third clock cycle. Now, fourth clock edge occurrence, I am feeding fourth bit information. Fourth clock edge occurrence, I am feeding fourth bit information. After fourth clock cycle, the 1 will be here. The 0 will be shifted. The 0 will be shifted. The 1 will be shifted to this. So this is the status of register after fourth clock cycle. After fourth clock cycle, this is the status of register. Are we getting 4-bit information at serial output port? No, we are getting only 1 bit. After fourth clock cycle, feeding information is completed, but I am not getting that 4-bit information at serial output port. How many clock cycles complete till now? Only 4 clock cycles. In 4 clock cycle, we are able to see first bit at serial output port. But I need to get remaining 3 bits also. I need to get remaining 3 bits also. For that, again, if you are shifting, the 0 will be available here. Then it will be 0. It becomes 1. It is again unknown. So now, after fifth clock cycle, we are getting second bit. One more clock cycle, sixth bit. Sorry, one more clock cycle, sixth clock cycle, one more bit, and one more clock cycle, one more bit. Finally, what is it here? To get remaining 3 bits, we need to have a 3 more clock cycle. So after 4 clock cycle, we are getting 1 bit. To get remaining 3 bits, 3 more shift operations in 3 more clock cycles. And what is it here? In 7 clock cycles. So after 4 clock cycles, we are getting only 1 bit. To get remaining 3 bits, we are taking 3 more clock cycles. Finally, what is it here? 7 clock cycles to get 4-bit information at serial output. To complete this operation, what we are observing? 7 clock cycle. In 4-bit register, to feed information serially, to get information serially. So serial input data, serial output data. To complete this operation in 4-bit register, in 4 clock cycle, feeding information is completed and we are getting 1 bit. To get remaining 3 bits, 3 more clock cycles. Total 7 clock cycles to complete the operation. If it is n-bit register, in n clock cycles, we are getting 1 bit only. To get n minus 1 bits, we need n minus 1 clock cycles. And finally, what is it here? 2n minus 1 clock cycles. Get n bit information. On n bit register, it requires 2n minus 1 clock cycles. Simple thing. Bit by bit serially, we are feeding. To feed 4-bit data, 4 clock cycle. But by the time we are getting 1 bit at serial output port. So to get remaining 3 bits, we need to apply 3 more clock cycles. So 4 plus 3 is 7 clock cycle for 4-bit register. If it is n-bit register, to feed n-bit information n clock cycle, then we are getting 1 bit. So In n clock cycle, we are getting 1 bit, n bit information feeding is completed. But in n clock cycle, we are getting only 1 bit. To get remaining n minus 1 bits, we need n minus 1 clock cycles. Finally, 2n minus 1 clock cycles to get n bit information. This is a serial input, serial output. To complete serial input, serial output operation, it requires 2n minus 1 clock cycles. 2n minus 1 clock cycles. Yes. Then it becomes asynchronous, Saujanya. Then it becomes asynchronous. It's a very big concept. When we are using two different clocks for all these flip-flops, then it takes a big analysis, which is nothing but a synchronizer and all. It becomes very big concept. I hope, right? This is a serial input, serial output operation. In this, for n-bit register, it requires 2n minus 1 clock cycles. 2n minus 1 clock cycles. Any doubts? Let me go with your doubts for today. Again, we resume tomorrow. Yes. Yes. Many are having doubt, right? Okay. Sanjeev. Sanjeev.
Hello, sir.
Yes, Sanjeev, tell me.
Good morning, sir.
Very good morning, Sanjeev.
Sir, I have a general doubt that what's the difference between latch flip-flop counters, sir?
Latch is level triggered memory element.
Okay, sir.
Flip-flop is edge triggered, it's a memory element. Using these memory elements, we are designing a counter which is going through a predefined sequence.
Okay, sir. Okay. Register also, we are using this flip-flop.
It's a counter. It's a counter.
Okay, sir.
Register can be considered as a counter. Not a problem. Right?
Okay. Okay, sir.
You're going to see that like ring counter, Janssen counter and all, then you'll get more clarity. That is that one.
Okay, sir.
Right.
Okay, thank you, sir.
Thank you. Chakrabarti.
Sir, 20th slide.
20.
Yes.
Okay. Whatever.
So suppose here if we change the order of x, there won't be any difference, right? In the out means like we will get the same answer as in right when
Same answer, wherever it is changing from 0 to 1 only, we get output is 1. You can change your own order. You can use 1, 1,
Okay.
0, 0. Right? Your wish. Not a problem.
And is there any possibility of getting a lockout situation here?
Here it is not having any lockout because
No,
if
it's
you are,
separate question means I means like will there be any such possibility, anything like that?
which one you are asking?
In this question means like
In this question, listen, in this question, lockout possibility is not there because X we have a control signal. Even though it is getting into some unknown state, we
Yes.
can make it to work by changing this X because we have a control. If it is a counter, then what happens, sir? Each and every input is from a given state.
Yes, sir.
Here we have a control X, right?
Okay, sir.
X can be given, we can make it as expected.
Okay, sir. And sir, the register that you have explained, that can also be done here also, right? Here, like we haven't considered that propagation that you are telling, like first clock cycle, second clock cycle. Here we just see that when Q1 is coming, we directly goes to Q2, and at the same time we are getting
same thing. Same
sir,
thing.
then why don't we consider here, sir, that thing?
Your register concept can be used.
Yes, sir.
Because here it must be 1 means it must be given as 0.
0.
Right?
Yes,
because
sir.
Previously we are expecting Q0 also 1, Q1 also 1.
Yes, sir.
But presently Q1 must be 1, previously it must be 0. If it is 0 only, it becomes 1 because we are getting here, input is not from Q1, input we are getting from Q1 bar. So whatever we have given earlier will be shifted to this, right? Shift register.
Yes, yes, yes.
So instead of giving Q1, we are giving Q1 bar. That is
Q1 bar.
We need to feed a 0, then we need to feed a 1. That's it. Register concept. Okay. Logically, if you are understanding registers, there you can understand here easily.
Okay, means
First
like the
feed a
same.
zero. First feed a zero, that will be shifted to this after next clock cycle. So as we are getting zero here earlier, it will be one. It will be shifted to this one after second clock cycle. So in the second clock cycle, if you are applying here one, here we are getting one. One is resulting one. Simple thing.
Okay, okay. So means like the same concepts are
Same
applicable here
concept.
also.
Same concept. Yes, same concept.
Yeah, okay, sir.
Very
Thank
good.
you, sir.
Yugasri.
గుడ్ మార్నింగ్ సార్.
Very good morning, Yugasri.
సార్ ఇక్కడ కాన్స్టెంట్ ఎట్ లాజిక్ 1 ఎప్పుడు వస్తుంది సార్? అంటే ఇప్పుడు అన్ని జీరోస్
ఇలా డైరెక్ట్ ఇచ్చామనుకో అమ్మా ఏమవుతుంది, ఇక్కడ వన్ రావాలి, ఇక్కడ వన్ రావాలి. ఇప్పుడు వన్ ఫీడ్ చేస్తే వన్ వెళ్ళిపోతుంది. క్యూ బార్ కాకుండా ఇక్కడ క్యూ ఇచ్చామనుకో ఏమవుతుంది, రెండు 1 అవుతేనే జెడ్ ఈక్వల్స్ 1 అవుతుంది. అంటే ప్రీవియస్ గా 1 ఇవ్వాలి, మళ్ళీ 1 ఇచ్చామనుకో అప్పుడు మాత్రమే జెడ్ 1 అవుతుంది.
అంటే అన్ని వన్స్ ఉన్నప్పుడు లాజిక్ 1 అవుతుంది.
లాజిక్ 1 అవుతుంది. ఇప్పుడు అండికేట్ కి అవుట్పుట్ 1 అవ్వాలంటే ఈ రెండు 1 అవ్వాలి కదా.
ఓకే సార్.
అంటే అలాంటప్పుడు ఏం చేస్తాం అంటే ఇప్పుడు ఇలా డైరెక్ట్ కనెక్షన్ అయింది అనుకో, ఇలా క్యూ బార్ కాకుండా ఇలా క్యూ ఇచ్చామనుకో ఫస్ట్ 1 ఇవ్వాలి, అది ఇక్కడ షిఫ్ట్ అవుతుంది. ఇక్కడ మళ్ళీ 1 ఇచ్చామనుకో ఇక్కడ 1 అయిపోయింది. 1 అయితే జెడ్ ఈక్వల్స్ 1 అవుతుంది. రైట్
సార్
18. ఓకే ఓకే
సార్ ఇక్కడ మనం ప్రెసెంట్ స్టేట్ లో ఫస్ట్ స్టార్టింగ్ 00 నే తీసుకోవాలి, ఏ నెంబర్ అయినా తీసుకోవచ్చా సార్?
ఏదైనా తీసుకోవచ్చు.
కానీ నెక్స్ట్ స్టేట్ నాకు అర్థం
ఇక్కడ
అవ్వట్లేదు.
చెప్పింది ఏంటంటే అజ్యూమింగ్ ఇన్ రీసెట్ కండిషన్ దట్ ఇస్ 000 అనుకో.
ఓకే సార్
ఇప్పుడు స్టార్టింగ్ 100 ఇచ్చారనుకో 100 స్టార్ట్ చేస్తాం, ప్రాబ్లం లేదు.
నెక్స్ట్ స్టేట్ నాకు అర్థం కావట్లేదు సార్, ఎలా వస్తుంది అనేది.
క్యారెక్టరిస్టిక్స్ యూజ్ చేసేమా. ఇప్పుడు ఈ స్టేట్ మీద డిపెండ్ అయ్యి ఈ ఇన్పుట్స్ రాయడం నీకు తెలుస్తుందా?
సార్
ఇన్పుట్స్ రాస్తున్నావు కదా.
ఎస్ సార్.
ఇన్పుట్స్ రాసిన తర్వాత JK11 అంటే JK ఫ్లిప్ ఫ్లాప్ క్యారెక్టరిస్టిక్స్ ఏంటి? JK11 కి నేను అందుకే చెప్పాను టేబుల్స్ పక్కన పెట్టుకోండి అని చెప్పాను. టేబుల్ ఉందని పక్కన
Q
ఆఫ్ ఎన్ బార్ కదా, Q ఆఫ్ ఎన్ బార్ కదా. Q ఆఫ్ n + 1 ఇస్ Q ఆఫ్ n బార్. అంటే నెక్స్ట్ స్టేట్ ఈస్ కాంప్లిమెంట్ ఆఫ్ ప్రెసెంట్. JK ఫ్లిప్ ఫ్లాప్ స్టేట్ ఏంటి కౌంటర్ లో? Q2 కదా. Q2 ప్రెసెంట్ కి ఏముంది?
0.
నెక్స్ట్ ఏముండాలి?
1.
0 బార్ అంటే ఏంటి? 1 అయింది కదా. T ఇన్పుట్ 0 అంటే నెక్స్ట్ స్టేట్ ఏంటి T ఫ్లిప్ ఫ్లాప్ కి?
Q2 is connected to T1.
ఒకసారి అమ్మ T = 0 అంటే క్యారెక్టరిస్టిక్స్ లో ఏముంది? Q ఆఫ్ n ఉందా?
Yes sir.
అంటే Q ఆఫ్ n + 1 Q ఆఫ్ n అంటే ప్రెసెంట్ గా ఏముందో అదే నెక్స్ట్ లో కూడా ఉంటుంది. అవునా?
ఓకే సార్.
D ఫ్లిప్ ఫ్లాప్ D ఇన్పుట్ 0 అయితే నెక్స్ట్ స్టేట్ ఏంటి? 0నే. D 0 ఉంటే Q ఆఫ్ n + 1 0. D 1 ఉంటే Q ఆఫ్ n + 1 1 కదా. అన్ని సార్లు D ఫ్లిప్ ఫ్లాప్స్ ఉండవు. D ఫ్లిప్ ఫ్లాప్స్ కనుక ఉన్నాయనుకో చాలా ఈజీ. ఎందుకంటే ఇన్పుట్స్ రాగానే తీసుకెళ్లి నెక్స్ట్ స్టేట్ లో పెట్టేస్తాం. అదే ఎప్పుడు అన్ని D ఫ్లిప్ ఫ్లాప్స్ ఉన్నప్పుడు. కానీ ఒకవేళ JK ఫ్లిప్ ఫ్లాప్, టాగల్ ఫ్లిప్ ఫ్లాప్, SR ఫ్లిప్ ఫ్లాప్ ఇచ్చినప్పుడు దాని క్యారెక్టరిస్టిక్స్ యూజ్ చేసి మాత్రమే నెక్స్ట్ స్టేట్ ఎస్టిమేట్ చేయాలి. అందుకనే టేబుల్స్ ఇంపార్టెంట్, బాగా చదువుకోండి, బాగా అబ్జర్వ్ చేయండి అని చెప్పాను. అవునా? డౌట్ ఏంటి చెప్పండి
సార్. NS ఫస్ట్ స్టార్టింగ్ మనం ఒకటి వేసుకున్నప్పుడు NS ఆన్సర్ ఏది వస్తుంది? 100 వస్తుంది. దాన్ని
తీసుకొచ్చి ప్రెజెంటేషన్ కింద
మళ్ళీ ప్రెజెంటేషన్
ఈ సైకిల్ రిపీట్ అయ్యే వరకు ఇదే చేస్తాం. ఇంకా
సార్ అట్లా అన్నప్పుడు 00 అనేది నెక్స్ట్ స్టేట్ లో వచ్చినప్పుడు మళ్ళీ దానికి రివర్స్ మనకు వస్తుంది కదా.
మళ్ళీ రాయాల్సిన అవసరం ఉందా? ఇది 00 నెక్స్ట్ స్టేట్ వచ్చింది, మళ్ళీ ప్రెజెంట్ స్టేట్ రాయాలి కదా. ఆల్రెడీ మనం అనలైజ్ చేసాం
కదా సార్. అంటే మీరు
మళ్ళీ అవసరం లేదు. ఇంకా
లాక్అవుట్ అని మళ్ళీ దీన్ని చేసినప్పుడు 011 అన్నారు.
వేరే ఇది వేరు, లాక్అవుట్ అన్నప్పుడు వేరు, ఇది వేరు. ఇవేంటివి? ఇవన్నీ ఏంటి? యూజ్ స్టేట్స్.
ఓకే,
ఇవన్నీ యూజ్ స్టేట్. ఒకవేళ కౌంటర్ ఈస్ గెటింగ్ ఇన్ టు అన్యూజ్ స్టేట్ అయితే కనుక ఏమవుతుందో చూసాం అంతే.
ఓకే సార్.
అన్నోయింగ్లీ కౌంటర్ ఈస్ గెటింగ్ ఇన్ టు అన్యూజ్ స్టేట్ అనుకుని చేస్తున్నాం అంతే. ఓకేనా? భవానీ
Good morning, sir.
Very good morning. Ma.
Sir, in the 19th slide,
Okay.
sir, in the question, if immediately is not given, then what is the answer, sir? Like for 10th clock, sir?
Should not be like that. If question is framed, you have to take care because even though it is not mentioned after 9th clock cycle, is go with that immediately. Otherwise, we cannot say what will be there after 10th clock cycle, right? Even if you are thinking also after 10th clock cycle, what will be there? I don't have the 10th bit data. I cannot say. There we can stop, right? Can we go further?
Not given, it is also 111.
Yeah.
Okay.
After 9th clock cycle, it is 111.
Okay, sir. Thank you, sir.
Thank you.
Hello, sir.
Very good morning, Praneeth. Tell me
Sir,
what
I
is the
think
doubt?
it's 20th, sir.
20th.
After 2 consecutive cycle changes.
Yes.
Sir, here, how you have taken this one, sir?
Changing from 1 to 0. We have to include 1 to 0. Changing from 0 to 1, include 0 to 1. Constant at 1, 2 ones must be there. Constant at 0, 2 zeros must be there. From the given options, I have chosen this data.
If you start from 1 to 0, sir, here you
Not a
have
problem.
taken
Not a
MSB
problem.
0, na, sir?
You can go with that also, right? You can start with 1, 0, 0, 1, 1, 0 also. Not a problem. You can go with that. Try. There also, you will be getting z equals to 1 when it is changing from 0 to 1 only.
Sir,
It is not compulsory to use this sequence only, but I wanted to cover these 4 possibilities.
sir, here
That's
if they are asked in 3 consecutive cycles, how do you take, sir?
then we need to have 3 flip-flops, right?
Okay, sir.
We need to have 3 flip-flops.
Okay.
Right?
Okay, thank you.
If you are interested, I'll give you such questions later, but not required.
Okay, sir.
Manisha.
Good morning, sir.
Very good morning, Manisha. Tell me.
Sir, today's first slide, sir.
Is this I think JK, yeah, this one only, right? This one is done yesterday only, right?
Yes, sir.
This one, yes, this one. Simple. JK flip flop, a counter, that's it.
No, sir, not that one, sir. Like,
This is the first slide for today. Yes, this is first slide. Today's discussion.
sir, wait a minute, sir, please, sir.
Yeah, you want to take that? Okay.
No, sir, no, sir.
Just take a snapshot. You can note it down later.
Sir,
Yes.
sir, normally you said that unused bits also will be there for some flip flops, right, sir? Like
Yes.
in mod 5 counter.
Here, in this counter, 1 is unused, right?
Yes, sir. No, sir,
Yeah.
not like that one. Like irregular order. Like
Irregular orders. Yes.
something like that.
Yes, it is possible. Yes.
Sir, then we
It's
won't say
irregular
like
order, right?
an order, like modulus counter will not be in an order, sir, like bits.
Actually, what you think is modulus means mathematical modulus is wrong.
Yes, sir.
With
Like
respect to
modulus
counter, listen. With respect to counter, what I discussed, the number of distinct states counter is going through. Did I say that it is a mathematical modulus? No. With respect to counter, modulus is always what is it here? The number of distinct states counter is repeating. Need not to be in order. Don't go with the mathematical modulus. Generally, what we think that mod 6 means it is 0 to 5, 6 modulo 6 is 0, 7 modulo 6 is 1, so and so. That is the mathematical modulus, but with respect to counters, modulus is the number of different states counter is repeating. It's called modulus.
Sir, I have a doubt. If we consider a 4-bit like 4-bit counter, then it is like a shift register, which shifts the data, no, sir.
Need not to be.
Then
Need not to be.
when it starts from original point to the ending point, the number of bits will it also acts like a modulus counter only, no, sir.
Which one you are talking?
So normally I'm asking a general question, sir.
What is the question?
Sir, when a like shift register starts from some 00 it shifts the data, na, sir.
Yes, shifting data. It is also
And
counter.
yes,
It is
sir,
also
it
counter.
comes back to 00, na, sir, at last.
That is depending on what type of construction you are using. See, here we have a external data, right? External pins are there. It is not a counter now. When we have external pins, it is not a counter. What is counter? It is going to predefined sequence. Is there any predefined? Do we have any predefined sequence of SI? No.
No, sir.
I can feed my own data, right?
Yes, sir.
Then it is not a counter. What is counter? A sequential circuit which is going to predefined sequence. Is it predefined sequence here? No.
No, sir.
There are other operations. When I say it is counter, it must be a predefined sequence. Then only it is a counter. Manisha.
Yes, sir.
Right. So it is not a predefined sequence because this external data is controlling what sequence it is going through. Is it predefined? No. We don't have any conditions for this serial input data. Then
Yes.
I cannot say it is a counter. When can we say it is a counter? We are going to see. Hold on.
Okay, sir. Sir, when we consider like a modulus counter with irregular order of data inputs, na, sir, for any irregular order of data inputs, but it starts from an original point and leads to the original point, na, sir.
See here, irregular order only, right? Is it increment or decrement? No. It is 0, then 4, then 2, then 7, then 1, again back to 0. It is regular order. It's a counter. No doubt in this, it is a counter. Because it is going through this sequence only, predefined sequence.
Yes, sir.
Right? It can be irregular order also.
Okay, sir. Thank you, sir. That's me.
Thank you. Thank you. See you tomorrow. Bharat.
Hello, sir.
Yes, Bharat. Tell me.
Yeah. Sir, in this 18F slide,
Mm.
so the question is initially all are at rest.
Okay, reset. Yes.
So we
All are
will
reset.
at reset means we will take 000 condition, right, sir?
Yes.
Or we can take any other condition.
It is all the flip flops are in reset condition, means it is 0, 0, 0.
Sir, once can you go to 17F slide?
Yes.
Sir, here all are in reset condition means
Hmm.
so the output Q2 will start from 0 only, no, sir? Like first option.
No,
What
no.
the
It is asked a sequence which is getting repeated, right? What is the sequence observed at Y? Sequence, when it is a cycle, do I need to start with this bit only? That means once it is completing here, it will be stopping there? No.
no, it is not stopping.
See,
Sir.
listen. When you are sitting in a circular,
Yes, sir.
you can start with any person, you can complete a cycle, right?
Yes, sir.
Same thing here also. It is circular, it is cycle. When it is cycle, why should I start with first bit 0 only? The sequence observed at y is, it is asked. The sequence, are you applying only this? How many cycles you are? It is 7 cycles only? No.
We are applying many more,
We are
sir.
applying at 70 cycles or 700 cycles we are applying. What will be there in repetition? Do we need to start observing from first bit only? No, I can observe from second bit.
Yeah, okay, sir.
Right.
And in 18F slide, sir,
Okay. What happened?
yeah, it is lockout, restart, and restart is there, no, sir.
Yes.
If they given a initial condition is 110,
110.
so we will get next state as 001.
0,
So
0,
then
1.
the
Coming to
normal
this.
procedure, it will repeat.
Yes, it is repeating here.
So here modulus will come to 6 or 5, sir.
Why only, right?
Yeah, so
Statement
we
must be understood correctly. Why? The number of distinct states counter is repeating. Is it repeating to 001? Is it repeating to 110? No. So first time only you are seeing that 110. Are we seeing that next time onwards 110? Statement. I know this type of doubts will be getting. That is the reason. The number of distinct states counter is repeating is called modulus of the counter.
Okay, sir.
Right? Understood now?
If
Don't say modulus of counter is 6, sir.
No, we can't say, but I have a little bit doubt in it.
Yeah, that's correct. That is the reason I clearly given the statement. What I mentioned, the number of distinct states counter is repeating is called modulus of the counter.
Yes, sir.
Right.
So if lockout is given like 011 as initial condition, then it is what will be, sir?
Lockout, right?
Lockout only, sir. If initial condition is 011.
That's what I've been saying. If it is 011, it will be 011 only.
Then modulus will be
1.
Okay.
1 state.
Yes, sir. That's all, sir.